Next speaker is Bruno. So, Bruno, the floor is yours.
Thank you very much. So the current project is about using SWAC in the Channel region. So it raises the question of doing SWAC in temperate regions. If I tell you about the SWAC system, the first idea that will come to you is this one. You see a tropical island with water that is pumped at 1,000 meters deep. The water, when it's at 1,000 meters deep, its temperature is about 4 degrees. So when you pump this water, you can directly air condition a building without doing anything. And the beautiful picture of a tropical island is Bora Bora, the Intercontinental Hotel, who is cooled with an air conditioning system. But when we are in temperated countries, we don't have the same thing. Here you see in the channel the difference between air temperature and sea temperature. You see on both screens, on both graphics, you have different colors for the different hours of the day. So there is something obvious. The yellow means noon, the black means midnight, and then the red ones are the morning and the blue ones are the afternoon. So you see that obviously we are going around the same temperature, but with the air we have a temperature difference, intraday temperature difference that we do not have during the in the sea. There I computed the difference between the sea temperature and the air temperature. When it's minus, that means that the sea temperature is colder than the air temperature, and when it's plus, that means that the sea temperature is hotter than the air temperature. So what we see is that the difference is much lower than in a tropical SWAC. In a tropical SWAC, you get water that is 4 degrees with an air temperature that is around 30 degrees. So you have more than 25 degrees of difference. Here we are somewhere between 8 degrees and -6. But notice again that during the summer, the hours where there is the biggest temperature are the noon and the afternoon, and during the winter, the hours where there is the biggest temperature are the night hours and the early morning. Now let's speak about the Newlyn site. You see that Newlyn site is completely in the end of Cornwall. So they are our twins as we are in Brest. They are as much in the end of the Earth as we are today in Brest. And they are in Penzance Bay, and the site consists on 2 containers on the south dock, and the containers, inside the containers, there is all the devices for the lobster
Lobster hatchery.
hatchery, for the lobster hatchery. So they pump water for their process of hatchery because they always need fresh seawater so that the baby lobster can grow up in the hatchery without being harmed. And the incoming pipe is going along the quay until the containers, and then it's used for the process, and the water is rejected in the sea just close to the containers. So for the moment, this water is took, but it is not used for thermal process. Here you see that the depth of the sea is not as interesting as it can be in tropical islands. We cannot go to deep sea. So the only thing we can do is use the water that we have close to our site. So now let's see a few pictures. You see a picture of the abstraction pump, and then pictures of the pipe network, pictures of the different filters, and you have the ultraviolet system also, and then the real hatchery process. This is for you to have an idea of what happens inside these containers. And here are the areas of improvement. The first one is for sunscreens and trickling. The second one is heat pump and chiller. And the third one is enhanced pumping, but I will not talk about the third one today. When we saw the difference between seawater and air water, there is something we completely forgot. It's that during the time where the air temperature is hot in the summer, there is a high rate of sun rays that heat the containers, and therefore the surface of the container is much hotter than the air. So we have, during the summer, we have to, the air conditioning system must face first the temperature of the air that might be too high, but second, and this is the most important, it must balance the rays of the sun that are going on the container. And so when there are rays, if you see on the left, you see the two containers, satellite image of the two containers, and in the middle you have a scheme of what happens. The rays are going on the container. There is one part that is refracted from the container, and the part that is not refracted is converted into heat. And this is what makes the metal of the container become very hot. And on the right side, I computed the amount of heat that is generated just by the sun. The one that is on the bottom is the amount of sun rays that are received by both sides of the container, the south face and the roof face. I didn't compute the other faces because they receive very little. And on the graphic on the top shows how much of this energy received on the container is transmitted inside the container. And you see that in a hot day, you will have between 40 and 50 kilowatt hour per day that is transmitted inside the container. So it's a lot of heat. So the idea was to make a mixed system with sunscreens that do not allow the rays to go on the container, and a coil that you see the blue coil that is fixed on the container to reduce the temperature of the container itself. And this is a way to use directly the water that is going on this coil is just plain seawater, and we can use it because the temperature of the surface of the container is much hotter than the temperature of the air. If it was just at the temperature of the air, it will not be enough. So with this, we can have some kind of free cooling. I did put again the graph with the temperature, the difference, the temperature difference between the sea and the air, because on next we are going to talk about heat pump and chiller. Heat pump and chillers, their efficiency relies a lot on the difference of temperature between the source of temperature heat that we have and the temperature we want to reach. The difference between these two will give the efficiency of the chiller. So this difference, what is the interest of having seawater instead of air? As we saw that there is very little difference between seawater and air. The first interest is that, as we saw on the graphic, on the hottest hours in the summer, which are the hours where there is the biggest demand in air conditioning, then the difference between water and air is quite important. It's about 4 degrees. That means that we win 4 degrees and we win in performance of the chillers. And the same, but reverse, for the coolest hours during winter. So the first thing is that during the times where there's the biggest, most important thermal needs, then the gain with seawater is more important. Second one is that the quality of the exchange with water is much better than with air. And third one is that with water exchanger, we can get rid of fine coils because fine coils in a marine environment will get destroyed very fast, and it can be a big problem with the. Thank you very much.
Okay, thank you very much for this. It's a very interesting outcome there from the study there regarding the slope hatchery in Newlyn. Any question